We interrupt this marathon grading session to bring you some breaking news. This just in, Drastic Engineering has completed preliminary development on a new project entitled Panoptes. What is this mysterious project? What will it mean for your weekend? We'll take you to our reporter in the field, Indy Handa Jones, for the juicy details.
Thanks, Pablo. I'm here at Indy Handapolis. Beautiful day out today. Chilly with a chance of seeing the moon all up close and personal like from the comfort of your own living room. How's that, you ask? Well, the folks out at Drastic Engineering, a new satellite, Panoptes, is in the works with preliminary development complete, testing expected for completion in 2020 and launch in 2021. The proposed destination, lunar orbit, with the potential to live stream video of the lunar surface to viewers just like you. You really gotta hand it to the folks out at Drastic. Pablo, back to you.
That sounds just about too good to be true, Indy Hannah. But what's the catch? We here at BSAE News conducted an exclusive interview with Drastic CEO Ham Sturwheel. Here's Chloe with what he had to say.
So how do you plan to provide video service to the average Joe, the everyman, if you will?
Well, that's a great question, Chloe. So, given the nature of this project, the funding has to come from somewhere. And we're no NASA, so we don't get your tax dollars. We have to take your money from some other source.
So that's where the Kickstarter comes in, right? To bring home the moon bacon, if you will?
No, I won't. But yes, that is where Kickstarter comes in. We use Kickstarter to generate revenue for development, build, and test of the Panoptes satellite. And once it's been delivered to orbit, access to the lunar live stream and our exclusive video library will be available on a subscription basis, which will allow the company to turn a profit and make our supporters' investments worthwhile.
A truly novel idea, yes. It's basically a Mayflower, if you will.
Again, you should really stop with whatever that is. Actually, the idea is derived from something the ISS is already doing. You see, the ISS downlinks footage of Earth's surface to NASA, but the idea hasn't made it past low Earth orbit and certainly not into the mainstream market. That's where Drastic hopes to innovate.
Fantastic. Back to you, Pablo.
Oh yeah, I'd love some coffee. Yes, thank you, Chloe. Yeah, I'm hearing now about a fascinating development to the story. We'll go to Edna Cheerios for more on that.
Yes, Pablo, we're receiving reports from here in downtown West Lafayette. The Drastic Engineering's launch contract has just been announced. Let's talk to one of the onlookers. What do you think?
I mean, geez, this whole thing just came out of nowhere. Drastic Engineering signed with Astrobotic to get their spacecraft launched to the moon. What was it called? Hamster bot?
I think you mean Panoptes.
Yeah, that. So, they signed with Astrobotic and they're gonna launch aboard a Falcon 9 and shoot that sucker up to the moon.
And that's to lunar orbit for our viewers at home.
Yeah, whatever that.
Okay, just to clarify for our viewers at home, that's an Astrobotic contract to launch on a SpaceX Falcon 9 delivered to lunar orbit in 2021. Back to you, Pablo.
Thanks, Edna.
When did you get here, Bruce? Bruce Prior, folks.
I got here about 12 seconds ago, but don't worry about it. In other news, Drastic Engineering's Panoptes project, not all it's cracked up to be. This reporter has been doing some digging of his own, and the dirt, it's juicy.
That's not dirt. That's mud.
Did I ask you? As I was saying, Panoptes just might not be as safe as it seems. Exclusive sources familiar with the situation are telling me that there are some serious safety risks, not to mention the financial and political risks should this project go forward. Let's take it to Peaches for the scoop on this juicy dirt.
Yeah, I'm pretty sure Pablo is right. It's definitely mud. Either way, I'm actually unfamiliar with your sources, Bruce, because I've been speaking candidly with Drastic design engineer Danny Dillmore, and he's been telling me about the upcoming project, and he believes that, unlike in West Lafayette, the forecast is full of sunshine. Would you like to comment, Danny?
Sure thing, Peaches. It's just like you said, the future is bright for Panoptes. We've conducted preliminary assessments of financial, scheduling, political, and safety risks, and are proud to say that we can proceed as planned with absolute confidence. A project like ours simply can't get off the ground without some financial risk, but we've prepared a three-tiered approach to maximize return on investment.
Tell me more.
Well, the concept is simple. If we raise a certain amount of money, we can deliver baseline capability. Add a little more, we can make significant improvements. And at full funding, we can go full steam ahead with peak capability and top-of-the-line features.
And as for the other areas mentioned?
Well, in regard to other risk areas, scheduling has been planned for very forgiving dates to minimize the chance of missing crucial deadlines, most notably the launch. Politically, we've made sure to avoid voicing any strong opinions on anything at all. And beyond that, we simply need to ensure that our satellite doesn't become space debris in lunar orbit. With experienced ground controllers, reliable launch vehicles, and adequate testing, this scenario is extremely unlikely.
I noticed you saved the best for last then.
Oh, yes, the all-important safety risks. We've prepared an elaborate FMICA.
Who's tight?
That's failure mode effects and criticality analysis. Yeah, you know what, don't worry about that. It means we've looked into the possible failure modes for each component and for the component interfaces, and we've established which of these risks are the most important to mitigate. Simply put, an extremely unlikely failure with minimal consequences is not usually worth worrying over, while a likely failure with catastrophic results is obviously much more important to deal with.
So how did this sneeze sound turn out?
Well, the FMICA revealed that most failure modes are pretty unlikely, with most of the risk being concentrated on launch, and then on operation in the space environment. Basically, we just beef up the structure, damp it well to reduce vibrations, and make sure all parts and lubricants are safe to use in space. That means no tin, no volatiles.
I'm going to pretend that I understood any of that, but it sounds just peachy to me. Heck, I'd ride on board myself.
You really would.
And now back to you in the studio.
Sounds safe to me.
Well, this reporter is not convinced. I mean, who does this satellite benefit anyway?
Oh, I am so glad you asked, Bruce.
What? How did you get here? You were just over...
Well, no. You see, we conducted a public opinion survey to gauge a potential interest in a project like Panoptes. The results were overwhelmingly positive, with the majority of respondents indicating they would be interested in viewing streamed video of a celestial body.
Are we just gonna let this guy talk all day?
Yeah, I'm good with it.
Oh, cool. So, our stakeholders will include, for the most part, educated consumers with a vested interest in the system who will most likely use the video stream or library service as an instructional tool. The remaining portion consists of people with a non-technical background who desire access to video for entertainment purposes. Over time, we hope this group expands to include the entertainment industry, which we feel would be tremendously benefited by access to high-definition video of planets and moons.
Well, that was a mouthful. Thankfully, this has been a special news report. We now return to your regularly scheduled programming.
Which, in this case, happens to be a BSAAE special on the making of Panoptes.
You've got to be...
Today, the making of a satellite, the Panoptes story. By now, we're all asking the question, how? How did Panoptes come to be? Well, that's a great question. So let's take a look. I'm your host, Brian Williams. No, not that Brian Williams.
Here with me today for an exclusive interview is Scruffy D. Janitor at Drastic Engineering. How are you doing today, Scruffy?
Yeah, I'm pretty sure you're talking to the wrong guy.
I think not. Let's begin. So, Scruffy, how does something like Panoptes get off the ground floor?
Look, I'm just the guy that mops the ground floor.
Interesting. Elaborate.
Okay, Brian, here's what I know. I overheard the bigwigs talking about the needs and requirements non-stop. It's like they're obsessed. From what I can make out, they're starting by identifying what their stakeholders will need from the system being designed in general terms. Something like, we need high-quality video, or we need to provide a variety of shots. Then...
Go on.
I was. Then, they translate these needs into engineering requirements. So for that first need, we might derive some multiple system requirements like the system shall provide a 1080p 30 frames per second video stream, and the system shall resolve detail to 1 arc second. Pretty nifty, huh?
Although literally no one uses the word nifty anymore, I'm inclined to agree with the sentiment. That's pretty funky fresh, if I may.
Who even are you? Oh, but I almost forgot to mention constraints. Constraints are like requirements, except that they must be met due to the nature or scope of the project. For instance, the mass of the satellite is constrained by the limits imposed by Astrobotic. It is mandatory that it weigh less than the limit. Requirements, somewhat ironically, are less concrete. If the system just can't, say, provide a 1 arc-second resolution, no matter how hard the design team tries, Drastic can proceed anyway if the project stakeholders are in agreement.
Wait, I'm starting to get a peculiar feeling here. I have a hunch you're not really who you say you are. Are you really a drastic engineer?
Is there anyone in this establishment with any kind of actual credibility?
Yeah, I think the code monkey's in his cage.
What? Someone say code?
What an interesting development. Let's go talk to this code primate. Can you tell us any of the technical characteristics of this Panoptes satellite?
So I have Cody Chimpson here, a programmer in the Drastic organization. Tell us what you know about Panoptes, Cody.
Oh snap, it's about to go down. Let me tell you about my boy Pew. So we used his legit method for concept selection. You know, to get from an abstract idea world to a concrete design land.
Is there anyone here that can translate for me what he's trying to say?
Oh, come on, nerd. It's not that hard. Basically, we throw out a bunch of ideas for each system component, and then we funnel away, combining some ideas, eliminating others, all based on how they compare against one another. We do that until, we have a cyborg idea that we can strap to a rocket.
Yeah, at this point, I think he's attempting communication.
Look, man, I'm just going to keep typing my stuff. I'm working on a pretty mean MATLAB code for my 532 homework.
Well, folks, I guess that's all the time we have for now. Thank you, Indiana, for joining us this evening. And remember, coming soon, look for a Panoptes coming to a moon near you.
So, to summarize, oh dear, we here at Drastic took an initial idea, lunar livestream, generated a list of stakeholders, and analyzed their respective needs. We then translated these needs into engineering requirements, generated initial concepts using a functional block diagram as well as Pew's method.
And then we narrowed down our concepts into a single hybrid design using weighted ranking methods. Basically, how well each potential design feature meets each requirement.
Swag. And from there, we projected the cost and value of the system at 3 tiers. Here's what our final design looks like.